Zener diodes are really interesting electronic devices. Here's a few symbols that I found. Seems to be a few ways to draw them. I was looking through the web and through several publications. I'm going to use the drawing all the way over to the right in my diagrams. I'm going to use this Zener diode in a simple circuit to show that a Zener diode will change its internal resistance, thus the current going through it, to keep, in this case, about 5 volts across the Zener diode. Here is the circuit. We have a 9-volt battery all the way over to the left, and that goes into a 330 ohm resistor, and across the battery and the resistor is our Zener diode. Then across the Zener diode is our load. Now I'm going to use a couple of resistors. Here you can see the setup, and we've got a 1K resistor in there. And then I'm going to take out that 1K resistor and put in a 560 ohm resistor. Okay, this is without a load. This reads 12.3, almost 4 milliamps. This reads a little over 5 volts, and of course we have 0 milliamps here. This is the Zener current, this is the voltage, and this is the load current. Now I'm going to add 1,000 ohms in the load current circuit. Now we have 7.4 milliamps here, a little over 5 volts here, and this reads just under 5 milliamps. In that first video clip, I did not have a load on the circuit yet, and what we have is about 12.4 milliamps going through the Zener diode, and we've got about 5 volts across the Zener diode. Then when I hooked up the 1,000 ohm resistor, then we have 7.4 milliamps going through the Zener diode. We still have about 5 volts across the Zener diode, and now through the 1,000 ohm load resistor we have 4.9 milliamps. Okay, we're back to no load again. This reads 12.4, a little over 5 volts, and of course no current here. I don't have a load on it. Now I'm going to put a load on this circuit of 560 ohms. Now this reads just about 3.9, 3.8, 7, 9, somewhere in there. This reads just slightly over 5 volts. And now this reads 8.6 and just a little bit more milliamps. In this second clip, we saw that when I put a load resistor of 560 ohms in the circuit across the Zener diode, we get about 3.8 milliamps through the Zener diode. We still have about 5 volts across the Zener diode and the load resistor is now drawing 8.6 milliamps. These two demonstrations show that when the load requires more current, the Zener diode increases its internal resistance, which lowers the current through it. But in both cases, with the 1000 ohm resistor and the 560 ohm resistor, the Zener diode maintains the voltage at about 5 volts.